Question 3 of 25. A project manager is estimating the length of time the project will take. The project manager worked on a comparable project 2 years ago that installed 10 miles of guardrails at a rate of 1 mile a day in similar weather conditions, using the same size crew on the same type of highway. What estimating technique would be the appropriate option for the project manager to use for his duration estimate? A. Parametric estimating. B. Analogous estimating. C. Bottom-up estimating. D. Three-point estimating. PMI knowledge areas and processes involved. Knowledge area, project schedule management. Process, estimate activity durations. Within the estimate activity durations process, the project manager identifies the type of estimating technique that best fits the available data and project context. Key definitions and best practices. 1. Parametric estimating. Involves using an algorithm or mathematical model based on historical data and project parameters, e.g., cost per unit, time per unit. When there is a known rate or productivity metric, e.g., miles of guardrail installed per day. Parametric estimating provides a scalable way to forecast the total duration or cost for the new project. Often yields good accuracy if the underlying data is reliable and the parameters are similar, e.g., same size crew, similar conditions. 2. Analogous estimating. Uses data from a previous, similar project to estimate the current project. Typically done early in the project when less detail is available. Provides a high-level estimate, generally less accurate than parametric if more specific data, e.g., known rates, well-defined parameters, is accessible. 3. Bottom-up estimating. Entails decomposing project activities into smaller components and estimating each piece before rolling them up into a total estimate. Highly accurate but more time-consuming. Typically requires detailed information about each task. 4. Three-point estimating. Based on the program evaluation and review technique, PERT concept, which takes an optimistic, most likely, and pessimistic estimate. Produces a range of probable outcomes, often used when historical data is insufficient or there is significant uncertainty. Rationale for the correct answer. A. Parametric estimating. The question explicitly states the project manager has data from a very similar past project. Installed 10 miles of guardrails at a rate of 1 mile a day in similar weather conditions, with the same size crew. These details are strong parameters or units of output, miles of guardrail installed per day, which can be applied directly to the new effort. The project manager can then extrapolate. If 1 mile takes 1 day, X miles will take X days. As long as the context, equipment, crew, weather, complexity remains roughly the same. This makes parametric estimating the most suitable approach. Analysis of the incorrect choices. B. Analogous estimating. While the new and old projects are indeed comparable, analogous estimating does not leverage the precise rate-based information. Analogous is typically used as a rough, high-level technique, whereas parametric uses concrete rate data, 1 mile per day. See bottom-up estimating. Would require estimating durations from the smallest work package level up. In this scenario, the project manager already has a solid metric, miles day, so a detailed bottom-up approach is unnecessary and more time-consuming. D. Three-point estimating. Applies best when there is uncertainty and a need to gather optimistic, pessimistic, and most likely estimates to derive a range. Here, the historical metric is strong enough for a direct calculation, so three-point is less relevant. Critical thinking tips. 1. Match the technique to the data. Whenever you see information about rates, productivity, or units of output per fixed resource or time, it typically signals parametric estimating. 2. Use analogous estimating for fewer details. Analogous is good early in planning if you only know that project A took 6 months. You compare it roughly to the new project. But if you have actual measurable rates, e.g. cost hour, miles day, parametric is more precise. 3. Reserve bottom-up for detailed scope. This is very accurate, but also resource-intensive. Wait until you need or have detailed work packages and WBS items. 4. Apply three-point when uncertainty is high. When you lack historical data or need to account for significant risk or unknowns, a three-point or PERT approach can help you bracket the range. Final takeaway. By recognizing that the project manager has definitive historical data regarding the rate of installing guardrails, parametric estimating is the most direct and accurate method under these circumstances.